Okay, so this time we're going to start looking at Poisson distributions. Now the key thing with Poisson distribution is you're looking for a question that's talking about a rate. So if something's happening at a certain rate, we kind of have the feeling that it's Poisson. We'll talk about the checks for why it's Poisson in the next video. But if you ever see that word per or on average, that's a giveaway that you're talking about a rate. So that kind of phrase there, you're looking for a rate, and that will give you the only parameter of Poisson distribution, which is lambda, the rate. And in this case, it's 2 misprints per page. So if we're asking to find the probability that there are no misprints, well, that's the probability that there are none. Probability x equals 0. So we're going to put into our calculator, or into the formula, you're welcome to use the formula, the probability that x equals 0. So if you're going to use the calculator, you're going to use ppd. Okay, P means it's at a point of exactly 0. Okay, so we want x equals 0, and we're going to come out with 0.1353. Okay, that's come with lambda being 2 and x being 0. Please stop the video and make sure that you can actually get that number in your calculator. Okay, now if there's more than 3 misprints on a page, how are we going to calculate that? Well, you need to start saying, what do I need? Okay, if I want more than 3, I want 4, 5, 6, 7, can have, I mean, you could really stuff up, right? You could have 100, but it's unlikely because they're averaging only 2. Okay, but we'll push off into infinity, and so that's going to be probability of x being more than 3 will be 1 minus the probability of all these ones, 0, 1, 2, and 3, which is 1 minus probability that x is less than or equal to 3. Okay, so we're going to now use PCD because we want the cumulative up to and including 3. If you're using the formula, you'll have to find the formula for probability of 0, probability of 1, probability of 2, probability of 3, add them all together. But this is a shortcut using CD. And we'll do 1 minus that. Okay, so you're going to look up 3. So that's going to be 1 minus 0.1804. Take that back. That's the most common mistake that people make. That number's come from using PPD. You need to be in PCD. Okay, and you'll realise the second you saw that number, it was quite small, right? And we're expecting that to be relatively large because we're expecting it to be the probability of 0, probability of 1, probability of 2, probability of 3, and most of the time they only have 2, so it's quite likely that they're going to have less than 2, and quite likely they're going to have around about 2, so we're expecting it to be a relatively decent probability. Okay, 0.8571. Now make sure you can get that number in your calculator. Okay, if you got the other one, you did the other mistake, right? So 1 minus that gives me 0.1428. So that probability of having more than 3 misprints on the page is 0.1428. So quite often they'll disguise that kind of question in another type of question, saying that the guy's going to get fired if there's more than 3 misprints on a page. What's the probability he gets fired? So you just need to interpret that question as summing it down to that. Okay, but that's the answer. We want to make sure that we all can actually get that in our calculator. So again, make sure you've stopped and gone through to make sure you've got that. Okay, there are exactly 2 misprints. Sorry, there are exactly 3 misprints on 2 pages. Now, lambda was 2 per page. So on 2 pages, we've now got a new lambda. Lambda must be 4. That's the key thing about Poisson distributions. We can multiply the rate by or divide it and change it to fit to how many pages or how many hours or whatever the question's asking us about. We just multiply or divide. Okay, 2 pages, there's 2 per page, so therefore there's 4. So the probability is exactly 3. We know x is 3. We're going to be in PPD again because that's exactly 3, and so we're going to say probability that x equals 3. You're going to go into your Poisson PPD, has to be PPD, change your lambda to make it 4, exactly 3, probability is exactly 3, that comes out to be 0.1953. Again, make sure you've got that. Okay? The second part of this. This is the same question, but we want to now talk about the fact that this magazine is misprinting on average per page. That's what the question's saying. How do we know it's Poisson? Well, misprints occur randomly. Okay. Now I want you to, same deal as with the binomial distribution, I need you to say this in more than just a sentence. More than just that sentence. I need you to add an extra. Then you add in the context. Magazine misprints occur randomly. Okay. You don't make mistakes deliberately. They occur randomly in your typing, and we'll accept that as sweet. Each mistake is independent of each other, so you need to justify that. If you're making a mistake, does it change the probability there's another mistake? Okay, you might want to talk about that, because that's be an interesting one to talk about. I'd suggest that if you've made one, maybe you're having a bad day, or maybe two and you're having a bad day, and you might more likely make more. But this is the assumption we need to make for this distribution to work. You can't make more than one misprint simultaneously. Okay? You either type a letter there wrong or it's right. You can't have two misprints in one spot. Okay? So you need to justify that as well. Now, that last bit is basically, word it however you want, as long as you're saying the probability is proportional to the size of the interval. Because at the end of the day, we multiplied that rate by 2 to get the probability, the rate for a larger interval for 2 pages. Okay, so we need to explain that situation. I need these all in words. I guarantee you need to memorize all 4 of these. It will turn up. So memorize them, put them in, and they also will mean that if you've got them memorized, you're much more likely to say the correct or pick the correct distribution.